Welcome to IGCSE and A-level chemistry classes. In this video, we are going to discuss about past paper 4 questions related to electrochemistry part 2. Okay, here first we have to discuss here question number 5. Question number 5, October, November 2008, question number 5. Okay. So see here in this question saying electrolysis of concentrated. You have to listen, you have to concentrate this point, you have to listen this point. Electrolysis of concentrated aqueous sodium chloride. Okay, this question related to electrolysis of concentrated aqueous sodium chloride. Okay. So during this process, look here, these are the ions formed Na plus, H plus, Cl minus, OH minus. Okay. Here concentrated sodium chloride, that's why here Na plus, H plus, Cl minus, OH minus. So we have to write the equation at cathode and anode. Clear? So to answer this type of question, look here. Here it is saying concentrated. Concentrated mean, we know concentrated sodium chloride mean, concentrated mean water. There is H2O. H2O produce H plus and OH minus. Sodium chloride mean NaCl. Sodium chloride mean NaCl. NaCl produce Na plus and Cl minus ions. So it is given already in the question, there is Na plus, H plus, Cl minus, OH minus. So we have to write just reaction taking place at cathode and anode. Clear? So you have to remember this is the electrochemical series. Electrochemical series. In electrochemical series, here K plus, Na plus, then H plus, Cu2 plus, Cl minus, SO4 minus, OH minus. These are the some ions. I didn't write all the ions, but you can remember here H plus, H plus. This is H plus. Group 1 in periodic table, group 1, group 2 ions coming above hydrogen, like K plus, Na plus, Mg2 plus, Ca2 plus. This type of ions will be above hydrogen. Okay, transition metals like Cu2 plus, Fe2 plus, it will be below hydrogen, and the lowest one it will be OH minus. Remember these things. Okay, according to this we can write reaction at cathode and anode. Now look here. Here reaction taking place at cathode. We know cathode, the charge of cathode negative charge. Cathode negative charge, anode positive charge. Remember this also, cathode negative charge. Okay, so cations will attack on cathode. Cations mean this is negative charge, so positively charged ions are coming towards cathode. Positively charged ions are coming towards cathode, Na plus or H plus. Okay, Na plus or H plus come towards cathode. So now look here, this is our reactivity series. Okay, here we have Na plus, here we have H plus. Okay, so which one is lower one? H plus is the lower one. So the lower one we have to choose. Reaction taking place at cathode, H plus, because H plus is lower one. Okay, so here H plus. Okay, in the previous video I told you reduction takes place at cathode, H plus. So here hydrogen 1 positive charge, hydrogen receive 1 electron giving H. Okay, also I told you in previous video. Okay, if you are watching this video before watching part 1, you must watch part 1, then you have to watch part 2. Clear? In part 1, I told you all halogen, oxygen, nitrogen, these are diatomic elements. So hydrogen we have to write in the form of H2. It's mean we have to multiply all this with 2. Okay, 2H plus, okay, 2H plus 2 electron giving H2. Okay, so this is the equation, this is the reaction taking place, this is the reaction taking place at cathode. Okay, 2H plus 2 electron giving H2. So at cathode hydrogen gas is formed. At cathode hydrogen gas is formed. Next one we have to write here reaction taking place at anode. Reaction taking place at anode. So we choose the hydrogen from this one. Next one we have Cl minus and OH minus. Okay, so again look here, Cl minus and OH1. OH minus is the lower one, lowest one, OH minus. Usually we have to choose OH minus except concentrated solution. Okay, in concentrated solution we have to choose halogen, Cl minus or Br minus. Okay, we have to choose halogens. Okay, in concentrated solution, only in concentrated solution. Okay, normal case Cl minus and OH minus, we have to choose OH minus because it is lowest one. But only in concentrated we have to choose Cl minus. Okay, so here it is concentrated solution, so we will choose Cl minus here. Also we discussed already at anode oxidation takes place. Okay, at anode oxidation takes place. Oxidation mean lose electron, Cl minus lose electron and change to Cl. Okay, Cl minus only one negative charge, so it lose one electron. Sometimes you have O2 minus. O2 minus mean 2 negative charge, so O2 minus lose 2 electron. Clear? So here Cl minus lose 1 electron change to Cl. Here no Cl minus, here Cl. Okay, Cl minus lose 1 electron Cl. But I told you before, Cl we have to write in the form of Cl2 because it is diatomic. Remember, all halogens are diatomic. F2, Cl2, Br2, I2. Okay, so here we have to write chlorine in the form of Cl2, means we have to multiply all this with 2. 2 Cl minus 2 electron giving Cl2. Clear? This is the reaction taking place at anode. Okay, so what are the product formed? So you have, sometimes you have the question, what is the product formed at cathode? Product formed at cathode, hydrogen. Product formed at anode, chlorine, Cl2. These are the product formed. Okay. Now, third question here, why the solution changed to sodium hydroxide? Here, third question, why solution turns to sodium hydroxide? Answer for this, look here, hydrogen deposit at cathode, Cl minus deposited at anode, at solution Na plus and OH minus left. This Na plus and OH minus combine to form NaOH. That's why solution turns to sodium hydroxide. Okay, so you have to say in solution H plus deposited at cathode, Cl minus deposited at anode, Na plus and OH minus left in the solution. This Na plus and OH minus combine to form sodium hydroxide. Clear? Here same question, part B. Why does the water supply industry use chlorine? In water supply we using chlorine. Why? We using chlorine gas. We will pass chlorine gas to water to kill germs and bacteria. To kill germs and bacteria we will use chlorine gas. Here next question, give one use of hydrogen gas. What is the use of hydrogen? Here we discussed hydrogen formed at cathode. So can you tell me what is the use of hydrogen? Here hydrogen Hydrogen used to make ammonia. Ammonia mean NH3. Okay, hydrogen and nitrogen reacted to form NH3. Okay, so the use of hydrogen used to make NH3. Here last question here. How sodium hydroxide used to make soap? How sodium hydroxide used to make soap? Here we discuss. Finally the solution turns to sodium hydroxide. Sodium hydroxide used to make soap. How? Here answer: saponification process means sodium hydroxide reacted with oil or fat and sodium hydroxide reacted together form soap and glycerol. This process is called saponification. Okay, again another question. May June 2009 question number 2. May June 2009 question number 2. Okay, here we have to complete this table. The results of experiments on the electrolysis using inert electrode. Okay, so using inert electrode there are different electrolysis and their results are given here. Already reactions and product everything given, but some this is a table. In table some columns are missing, we have to complete it. Okay, here one example is given. Using this example you have to read this example. According to this you have to complete rest of the table. Here electrolyte is there, electrolyte, product formed at negative electrode. Negative electrode mean I told you before cathode, positive electrode anode, then change of electrolyte. Okay, also we discussed before aqueous sodium chloride changed to sodium hydroxide. That is the change of electrolyte. Sodium chloride changed to sodium hydroxide. Okay, this type of information you have to complete here. So first one, look here, we can answer according to this one. Here first one dilute here first one potassium formed. Here already given at negative electrode cathode potassium formed, anode iodine formed. Potassium and iodine. Okay, so potassium and iodine only. There is no any information about hydrogen and oxygen or anything. Okay, so you can say here molten potassium iodide. Here it will be electrolyte will be molten potassium iodide. Okay, remember if it is aqueous substance, aqueous or dilute or concentrated mean there will be water, H2O. H2O mean there will be H plus and OH minus. Okay, so if it is aqueous, dilute or concentrated, so in product there will be hydrogen gas, or there will be oxygen gas. Okay, so aqueous, dilute, concentrated mean there will be water. Okay, and in product side there will be hydrogen gas, or sometime you can see there is oxygen gas. So here only potassium and iodine, no hydrogen, no oxygen. So we can say here it is molten compound, not aqueous. It is molten compound, molten potassium iodide. It is molten potassium iodide. Clear? Next one here, next table it is given dilute aqueous sodium chloride. It is dilute aqueous sodium chloride, not concentrated. It is dilute aqueous sodium chloride. So remember here dilute aqueous sodium chloride. Dilute mean I told you water, H plus and OH minus. Sodium chloride mean Na plus and Cl minus. Sodium chloride mean Na plus and Cl minus. Clear? So here we have to write here we have to write product formed at cathode. Negative electrode mean cathode. Okay, so cations will come. Cation mean H plus or Na plus. H plus or Na plus coming towards cathode. Okay, I show you here before reactivity electrochemical series, Na plus and H plus. H plus is the lowest one. So here H plus will deposit at cathode. Okay, so here we have to write 2H plus plus 2 electron giving H2. This is the product formed at cathode. Clear. Next one we have to write here product formed at positive electrode anode. We have to write the product formed at anode. Anode anions are coming. Anions mean OH minus or Cl minus. OH minus or Cl minus. So which one we have to choose here? We have to choose OH minus, not Cl minus. We have to choose OH minus. OH minus is the lowest one. Clear? So OH minus. So remember the equation for OH minus. OH minus lose electron and it will change to water and oxygen. You have to remember this equation. OH minus lose electron and form water and oxygen. Clear? Look here, this is, we have to balance here. Look here, left hand side 1 hydrogen, here 2 hydrogen. Here right hand side 3 oxygen, here only 1 oxygen. To balance this, here 4 OH minus. Okay, look here, 1 OH minus lose 1 electron. So 4 OH minus lose 4 electron. 4 OH minus minus 4 electron, 2 H2O plus oxygen. Now it is balanced. You have to remember this equation like this. 4 OH minus minus 4 electron giving 2 H2O plus O2. Now it is balanced equation. Okay. So this is the reaction taking place at anode. Clear? So look here. Here third table we have to write the change of electrolyte. Okay, so here we choose hydrogen we choose at cathode. Okay, OH minus we choose we selected OH minus at anode. So what is left here? Na plus and Cl minus. So Na plus and Cl minus combine to form sodium chloride. So electrolyte changed to NaCl, sodium chloride. Clear? Here next question, aqueous copper sulfate. Okay, so aqueous copper sulfate, electrolyte is given aqueous copper sulfate. So you have to write what will be the product at cathode, what will be the product at anode. Look here, electrolysis of copper sulfate. You learned 2 different type of electrolysis copper sulfate. Electrolysis of copper sulfate using copper electrode. Electrolysis of copper sulfate using carbon electrode. Okay, so here it is already given in the question, it is inert electrode. Inert electrode mean carbon electrode. Okay, so here we have to choose electrolysis of aqueous copper sulfate using graphite electrode or carbon electrode. Clear? So look here, aqueous copper sulfate mean, aqueous mean water, there will be H plus and OH minus. Copper sulfate means Cu2 plus and SO4 2 minus. Clear? So we have to write here, product formed at cathode. So here copper sulfate. Okay, so here H plus and Cu2 plus. Here Cu2 plus is the lower one, Cu2 plus below hydrogen, so we have to choose Cu2 plus. So Cu2 plus plus 2 electron giving Cu. This is the reaction for copper. So the product formed at cathode, product formed at negative electrode, it will be copper. Clear? Next one here we have to write the product formed at anode. We have here OH minus and SO4 2 minus. I told you before, OH minus is the lowest one. Okay, so we have to choose OH minus. Also we discuss equation for OH minus, 4 OH minus minus 4 electron 2 H2O plus oxygen. Here you have to write product formed. So what is the product formed? Oxygen is the product. So you just write O2. Here also no need to write this equation. You just write O2 here. Okay. Here O2. Here you have to write H2. Here you have to write copper. You just write only the product formed at the electrode. No need to write complete equation. Clear? So here at anode oxygen, at cathode it is copper. Clear? Next one here, before starting next one, change of electrolyte. Also here we discuss now product formed, electrolysis of aqueous copper sulfate, product formed at cathode copper, product formed at anode oxygen. Okay, also there is another table you have to complete. Change of electrolyte. So here you choose the copper, you choose the OH minus. So what is left here? H plus and SO4. Okay, H plus and SO4 combine to form 2H plus SO4 2 minus. So solution will turns to H2SO4 sulfuric acid. H2SO4 solution will turns to sulfuric acid H2SO4 because in solution H plus and SO4 left. Clear? Next one, look here, next one, electrolysis of aqueous potassium bromide. Okay, here electrolyte is not given. Here it is given product formed at cathode, it is hydrogen. Product formed at anode, it is bromine. Okay, bromine, Br2. Okay, so Br2, anode it is Br2. Okay, so it will be aqueous KBr, aqueous potassium bromide. Aqueous potassium bromide means there will be K plus, there will be Br minus, K plus Br minus, H plus OH minus. Okay, and here it will be concentrated KBr, aqueous concentrated potassium bromide. That's why concentrated potassium bromide, that's why Br minus deposited at anode, not OH minus. Okay, normally OH minus will deposit at anode. I told you, except concentrated solution. In concentrated solution, halogens will be deposit at anode. So here halogen Br minus, Br2 is the product at anode. So this solution is concentrated one. So here it is concentrated. Okay, and also here K plus and H plus. H plus is lower one. So H plus deposit at cathode. So here you have to write here electrolyte is concentrated, aqueous concentrated potassium bromide. This is the electrolyte. Clear? Okay, these are the different questions we are discussing here. And if you have any problems to solve any past paper question related to electrochemistry, you just write the question number and year in comment box and I will help you to solve that question. Okay, so thank you for watching this channel. You can subscribe, share to your friends, like this video. Okay, so thank you. We will see you next video. Thank you.